Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello students, welcome back again to this learning series program. I'm teacher Patrick, and today I'll be taking you through chemistry practicals. Basically, in these practicals that we are just going to look at, I just wanted to take you through the number of ions that we are going through, the number of cations that we have here. And we have iron 3 ions, we have iron 2 ions, we have a solution of potassium iodide, we have a solution of potassium hexacyanoferrate 2, we have a solution of potassium thiocyanide. We have a solution of potassium hexacyanoferrate 3. We have a solution of lead 2 ions, a solution of potassium chromate, a solution of zinc 2 ions, a solution of copper 2 ions, and we have a solution of chromium ions, a solution of cobalt 2 ions. We have sodium hydroxide, and then we have ammonia solution. So these are the solutions that we have. And as we look here in front of me, we are just going to identify, we are going to use the sodium hydroxide or ammonia solution to identify the cations that are present here, and we make the observations. Remember, if we consider, if most of you take bottled water, if you can maybe grab just a bottle of water, when you look at the bottle outside, there are some of the information that is written there. You will find in the ingredients, you will find there some magnesium ions, you'll find there some sulfate ions, the chloride ions, probably the iron 2 ions, and many others. So for the certification by the Rwanda Standard Board for this bottled water, I believe, to be certified and be able to be consumed by the human beings, then this the Rwanda Standard Board must carry out these experiments to find out whether those ions are present, or probably if they find they are not, then that means that maybe that water may not be fit for consumption. Because these ions are very important for our bodies. Let me talk about even the iron, these iron 2 compounds. Our blood contains iron. The blood appear red because of the presence of the iron solution. That is why we need, even our bodies, we need iron. But we take this iron from the different components of food. We are not going to take this solution because it contains iron, then to get the iron 3. Or we are not going to eat an iron bar because it contains iron. So we get these components from the foods that we take. So we are just going to look at this, carry out different tests, and then we see what happens if those ions are subjected to either sodium hydroxide or ammonia solution. Or we may use even these other solutions, potassium thiocyanide, potassium hexacyanoferrate 2, or potassium hexacyanoferrate 3, or potassium chromate, and so on. So here we'll be looking at the identification of cations. And we have a number of cations, as I've mentioned before. You look at some of them, have very interesting colors. Look at this one. Look at this one. They are very interesting colors. Look at this cobalt. So these, the ones that are colored, just take a look at this one. This is the periodic table. These elements here, I hope you remember the general name that is given to these elements here. We say they are called de Broglie elements. So these are transition elements. And mainly, if you remember, transition elements form colored compounds. So the compounds of transition elements are colored. Take an example of this one. This is copper. It is one of the transition elements. Take an example of lead, of chromium. Take an example of cobalt. You'll see they are also colored, and they are also found here. We have iron, we have cobalt, we have chromium, and maybe zinc is unique because it forms a colorless solution. Probably you talked about it in your revision. So we are just going to start right away, and I need you to pay attention. I ask you to pay attention and see what is going to happen. So we are starting with this iron 2. So you don't need to use a lot of solutions when you are carrying out these experiments. This is a solution of iron 2. And we are just going to add, sodium hydroxide. Sorry. I'm just trying to cover up this iron 2 because you remember iron 2 is a very unstable compound. It easily turns into iron 3 in the presence of oxygen. So that's why I have to cover it again. And all the solutions have to be covered. So I'll use sodium, this is sodium hydroxide, and I'll add some few drops. See what is happening? Something jelly-like. So sometimes we call it gelatinous. It is a precipitate. So let's add excess. Looks, what type of color, what kind of color is that one? So the precipitate is insoluble. It doesn't dissolve. So it is not disappearing. So this is green precipitate. So what happens with this? This is what happens here. So you have a solution of iron 2 ions. It is reacting with sodium hydroxide. So the sodium hydroxide produces the OH ions, the hydroxide ions, coming from the sodium hydroxide, and then it forms iron 2 hydroxide. This is the green precipitate. Green precipitate, and it is insoluble in excess sodium hydroxide because I've added excess. So that's what happens. So we are just going to look at the same solution. We are just going to see the effect with the with ammonia solution. Please take note. We have, you see, we have different droppers here. Whenever you are carrying out an experiment, there are guidelines you need to remember always. Don't interchange these droppers, so because you'll get wrong results. So be careful whenever you are carrying out these, what we call the qualitative analysis. So in the next, we are just going to look at the effect of ammonia solution. This is ammonia solution. And then with the same reagent, with the same iron 2, and then we'll see what happens. Please, I said you don't need to use a lot of solutions with this qualitative. Make sure you remember to cross because, as I've said earlier, iron 2 is very unstable, so it easily changes to iron 3. So this is, I'm just going to add some few drops of ammonia. Are you seeing what is happening? Is there any difference? I think there is no difference. This is some few drops, so I can add excess. So it's the same, a green precipitate. In most cases, we call it dirty green because it doesn't look clean, so we call it dirty green. So it's the same reaction. So iron 2 ions are reacting with the hydroxide ions, the same hydroxide ions. But this time, the hydroxide ions are not coming from sodium hydroxide. They are coming from ammonia solution. Ammonia solution is ammonium hydroxide. So this forms still the same precipitate, which is green precipitate, and it is insoluble in excess. So let's see what will happen later. So if we're coming back to this one, as I said earlier, I need to take note of this. The iron 2 easily changes to iron 3. So on standing, this dirty green, so it was like this. But if you take a close look at this one, it is turning to brown. Why is it turning to brown? Because it is changing to iron 3 hydroxide. That is because of aerial oxidation. So we are just going to look at, we do the same with iron 3. So this was iron 2. Then we'll see the difference. This is iron 3. So just take a few drops of iron 3. Two or 3 cubic centimeters. Then we can also look at sodium hydroxide. We'll also add some few drops. Wonderful. So you see, this is iron 3. This is a precipitate. Remember precipitate. Precipitate looks like this. So it is reddish brown, or you can call it brown. So this is iron 3. So this is mainly, this can also be called rust. No rust that can destroy the metals. It's because of this iron 3. So we have iron 3 ions reacting with the hydroxide ions from sodium hydroxide and then giving iron 3 hydroxide. This is a brown precipitate. It is also insoluble in excess with sodium hydroxide. Look at the precipitate. It is also a gelatinous, looks like a jelly-like. So the same solution, we are just going to look at the effect with the sodium hydroxide, with ammonia, because we have finished with the sodium hydroxide. So let's look at the effect with the ammonia. We have to start with iron 3. Add some few drops, 2 or 3 cubic centimeters. And then add some few drops of ammonia solution, drop-wise. This is what we call drop-wise. Gelatinous, that is the same precipitate. So it gives, still we are having iron 3 also reacting with the hydroxide ions, giving iron 3 hydroxide, this is a solid. It is the same, it is precipitate as well. So we'll proceed looking at these solutions with potassium hexacyanoferrate. So these, the tests I've finished are called preliminary tests. Preliminary tests, so we can carry out the confirmatory tests. So with the iron 3, I'll just look at the effect of potassium thiocyanide with the iron 3. Right. That's iron 3, some few drops. Then we can add potassium thiocyanide. Oh. See what happens? Red blood coloration. Red blood coloration. So let's see the effect with iron 2, whether it gives the same effect. This is iron 2. Some few drops again. Any effect? Nothing. So that means potassium thiocyanide with iron 3 gives this red blood coloration, but with iron 2, there is no observable change. So that means we can use potassium thiocyanide to distinguish these two ions, the iron 3 and iron 2. Let's also look at also carry out. We just see the effect with the potassium hexacyanoferrate 2. Let's start with the iron 2. Also some few drops of iron 2. If I forget to cross, please, you remind me. I can also cross because I may forget. So this is some few drops of iron 2. Then we are just going to add potassium hexacyanoferrate 2. Iron 2 with potassium hexacyanoferrate 2. Let's see what happens. This is looks a blue precipitate. This is a blue precipitate with iron 2. And then let's check what happens with iron 3. The same hexacyanoferrate 2. Now we go to iron 3. Some few drops, as I said earlier. Then add very interesting color. So this is dark blue precipitate. Dark blue precipitate. See what happens with iron 2? This is the difference. This was for iron 2. Now this was for the iron 3 with potassium hexacyanoferrate, and this was iron 3 with potassium hexacyanoferrate. So you see this is the dark blue, so meaning that this potassium hexacyanoferrate can also be used to distinguish these two cations as well. So let's look at the potassium hexacyanoferrate 3 with these two compounds, iron 2. So we have this iron 2 So we are going to look at with this one. Iron 2 first, said some few drops. Then we'll have to look at the, now we'll add potassium hexacyanoferrate 3, iron 2 hexacyanoferrate 3, two with 3. Can you see what is happening? This was 3, iron 3 with hexacyanoferrate 2. This one here, this is then 2 with hexacyanoferrate 3. They give the same results, the same observation. This one is called Turnbull's brew or Prussian brew. So, but they are all the same. Turnbull's brew or Prussian brew, they are all the same. Iron 3 with hexacyanoferrate 2. Iron 2 with potassium hexacyanoferrate 3. So those solutions can be used. The solutions can be used to distinguish between these cations. Iron 2, for iron 3, even if you don't cross, there is no big problem because it is very stable, as I said. So you need to make sure you cross, especially the iron 2 compounds, don't forget. So there is no, the difference here is the reagent that you can use to distinguish. So from the beginning, we have mentioned a number of reagents, and this is what happens. So if we use ammonia solution, if you use ammonia solution, I said ammonia solution is also ammonium hydroxide. So a solution of ammonia, so we usually write it in this form, or we write it in this form. So with iron 2, if you remember, we said with iron 2, with ammonia, you are getting, said dirty green precipitate, which was insoluble. With iron 3, we are getting reddish brown precipitate, which is also insoluble in excess. So meaning we can use ammonia to distinguish between iron 2 and iron 3 because they give different reagents, different observations. When you use, you can use ammonia or you can use sodium hydroxide. Sodium hydroxide, the reagent observation, you still remember the observations? Some of them are still here. So we said when you use sodium hydroxide with iron 2, we are getting also a dirty green precipitate, or which we said it can also be called a gelatinous dirty green precipitate, which is insoluble in excess. And when you use iron 3, the same, we said we are getting brown precipitate, also insoluble in excess. So those either sodium ammonia solution or sodium hydroxide, you can use any one of them. Or you can use, as we said, potassium thiocyanide. The potassium thiocyanide, this is another reagent. And then, if you remember, I said these two are called preliminary tests. Preliminary tests. And then we have confirmatory tests. In the confirmatory tests, there are three, we are using three different reagents. We are using, one of them was potassium, potassium thiocyanide. You remember what happened with this? So with iron 3 ions, there was red blood coloration. With iron 2, there was no observable change. If we used potassium thiocyanide, so we also used another reagent that we can also use. We looked at the potassium hexacyanoferrate. Potassium hexacyanoferrate or potassium ferrocyanide, or we used potassium hexacyanoferrate 2 all these ones. We have seen that they are the ones that we can be used to distinguish these two cations. Then I just want to give you, before we wind up, I would like to give you just one simple exercise. So using equation, state any reagent that can be used to distinguish iron 2 and iron 3, give relevant observations, and you'll answer that one. And I wish to stop here for this time, and I will be with you. The cations that we have not looked at, we'll also look at them in the coming lesson series. So I thank you so much for listening and observing. See you next.